Hello everyone, so today we're on our last section for gas laws, yay! And we are talking about the ideal gas law. So your topic is the ideal law. Your goal is I can solve problems that involve pressure, volume, temperature, moles, yes, we're still talking about moles, and the constant, which I'll make this to where you guys can see, and the constant of gases. So what makes this one a little bit different than the others? The others we had a starting like temperature, pressure, whatever variables we're talking about, and a new temperature or pressure or volume. Whereas the ideal gas law, we're using a formula where we have all the variables except for one, and we're solving for that one variable. Nothing's old or new, it's just all different pieces of information. So for that, we have our ideal gas law formula. It is PV equals nRT. P is our pressure, V is our volume, N is moles. So that's something a little bit different. They can't put M because little m is mass or molality, which we'll talk about in another unit. So they had to pick a different letter, which they picked N. So N is moles. R is your universal gas constant, which I talk about right here. Depending on which units you use, we will use this first one, and I always give it to you in the problem as well. And then T is our temperature. Hopefully by now you know temperature has to be in Kelvin. So if it's in Celsius, you add 273, and that puts it in Kelvin. All right, so here I went ahead and tried to fix it to where it's a little easier to see the problem since we have so many variables. And we have this example for you to do. So I do want you to type this example out in your notes. So calculate the pressure in atmospheres of 0.412 moles of helium at 16 degrees Celsius, and you have 3.25 liters. So we are looking for pressure.
Ethan Deal, come to the office, please. Ethan Deal.
We have 0.412 for our moles, or N. Our temperature is 16 degrees Celsius, so we have that, but we need to change that to Kelvin, so you will do 16 plus 273, so 289 is our temperature, 289 Kelvin, and occupying 3.25 liters, that's our volume, so 3.25 liters. All right, so now that we know what's given to us, we can kind of fill it in this formula. Our P is X, because that's what we're looking for. Our V is 3.25 equals our N, which is 0.412, 0.412. Oh, I also forgot, I do give you R. R is 0.0821. I'll always give that to you so you don't have to worry about finding that. So our moles is 0.412 times our R, which is 0.0821, times our T, which is 289. 289. See, make sure we can get that all in one row. All right. So now let's kind of do some math. So that would just be x and then 3.25 equals, and then we'll multiply those three numbers together in our calculator. So 0.412 times 0.0821 times 289. When we multiply those, we get 9.775. So we'll say 9.8. 9.8. Okay, to get x by itself, we have to, since 3.25 is being multiplied, we have to do the opposite. So we will divide by 3.25 on both ends. There we go. Alright, so 3.25 and then 3.25, which that does not need to be underlined. Alright, so now that we have that, equals, oh my, I'm on the struggle bus today. Okay, so equals, x is, you do 9.8 divided by 3.25, which is 3. And we found pressure, so that would be ATM, and that is our answer. So in your digital notebook, I have the formula for you right here, and on the practice page, you do have 5 of these just because we've done a lot of the other problems combined together where this is different than all the others. I wanted to give you a couple more examples. Now remember, N is moles. Your R, I'm going to write up here for you because I just noticed it is not on every single problem. So R equals 0.0821. Make sure that's correct. Double check myself. Yep. So every time in this problem, R is going to equal this number. P is pressure, V is volume, N is moles, R is your constant, which is always that number. T is your temperature. Remember, it does need to be in Kelvin, so if it's in Celsius, add 273, and then you will be good to go. If you have any questions or need me to check your work, let me know, and I will be happy to help.